For this video, we'll be talking about section 4.3, which is slope-intercept form. To start, we have some vocab here. An equation of the form y equals mx plus b, where m is the slope and b is the y-intercept, is written in slope-intercept form. Next, we have the variables m and b are called parameters of the equation because changing either value changes the graph of the function. And then we have a constant function is a linear function of the form y equals b. These functions, as long as b is not 0, do not cross the x-axis. The graphs of these functions have a slope of 0. Basically, if you remember, if we have y equals a number, this is a horizontal line. And that's why it doesn't ever cross the x-axis, because if you think of the horizon, it would either be above the x-axis or below the x-axis. And again, that's why it says as long as b is not 0, because if it was y equals 0, it would be on the y-axis, or I'm sorry, on the x-axis. Otherwise, it doesn't cross the x-axis. So horizontal line there. Next, we have the idea of Hoy-Vux. So this is something that actually gets referred to very, very often. So it is something that we definitely need to make sure we understand. And it's just an acronym to help us keep a bunch of information straight. So looking at Hoy, this stands for certain things. The H stands for a horizontal line. So the next two letters are going to be about horizontal lines. So if a line is horizontal, the O stands for the fact that it has a 0 slope. You'll kind of remember we just talked about that with the constant function. The Y here is probably one of the most important ones that gets misunderstood. A lot of people think it's the y-intercept. No, no, no. This is the equation. And it's y equals a number. Every single time. If it's a horizontal line, if you're told that the slope is 0, you know for a fact the equation is y equals a number. Now, very similar for Vux. So instead of a horizontal line, we're going to have a vertical line. And then instead of having a 0 slope, this would have an undefined slope. And then x, very similar to y. This is the equation. Again, it does not mean it's an x-intercept at all. It's the equation of the line is x equals a number. So with that being said, we're going to have a bunch of examples here on the front. Looking at number 1, it says write linear equations in slope-intercept form. So starting with number 1, we need to know m and we need to know b in order to write an equation in slope-intercept form. Because remember, that's y equals mx plus b. So we need to plug in m and plug in b. Y and x are going to stay the same every single time. Slope is m, y-intercept is b. So then that means this answer would be y equals m, which is 4/7. X would go next to it, and then plus b would be plus 5 because it's a positive 5. Number 2, slope is m, -5. So y equals -5 times x. And then the y-intercept is -12. This is our b value. So we are not going to put plus a -12. We're just going to put -12 here. So remember, going back to that same rule from before, we never ever put plus a negative. It is either a plus or a minus. You need to make a decision about which one you're going to plug in there. Now, on number 3, if the slope is 0, immediately I should start thinking of Hoy because that's part of Hoy. That's where this acronym is going to be really helpful, is if certain pieces of information apply for Hoy or Vux, you can use the rest of it to figure out what your answer is. These directions say write the equation. The equation would be part of y in Hoy. So remember, from up above, the equation is y equals a number. In this case, it's going to be y equals -6. That's how you would use Hoy there to help you out. Very similar to that, we have a slope that's undefined. This would be part of Vux. Again, certain pieces of information have to start jumping out at you for Hoy and Vux to be helpful. Since it's undefined, we know it's Vux and not Hoy because the U is in Vux. Now, I'm still writing the equation. The equation is the last letter x, meaning it is x equals a number. So in this case, it would be x equals 3 because that's the x-intercept they give us. 5 and 6, we are rewriting it in slope-intercept form. So again, still going for y equals mx plus b. The biggest thing to understand is we are trying to get y by itself. In order to do that on number 5, I'm going to put my box around y, if you remember doing that from a long, long time ago. So I need to get everything away from y. I have to undo adding or subtracting first. I see adding 16x. So we're going to subtract 16x from both sides. When we do that, we have negative 4y equals, those canceled out. Now, between these two things, I need it to be in the order of slope-intercept form. The x term has to come first. So I'm going to start with negative 16x and then write minus 56. So the order of those two does matter. In order for it to be in slope-intercept form, x has to come first, then the b term, the constant can come next. After that, now, first of all, we do not combine these because these are not like terms. One has an x, the other does not. So those are definitely not going to get combined together. After that, we're still trying to get y by itself. So then this is where I would divide everything by negative 4. And again, we are dividing every single term by negative 4. So separate fraction bars here. And then we're going to simplify everything accordingly. So those negative 4s cancel out. I have just y left, which was my goal. And then I have to simplify negative 16 divided by negative 4. Two negatives make a positive. 16 divided by 4 is 4. Still have to bring down that x with it. And then we're going to simplify negative 56 divided by 4. Two negatives again would make a positive. And then 56 divided by 4 would end up being 14. So that is our answer in slope-intercept form. Looking at number 6, again, our goal is to get y by itself. So we're going to add 12x to both sides. First, we have to get rid of that x term. So we have 8y equals, again, these are not like terms. We do not add them together, but they do matter what order they get written in. So 12x is going to go first, and then I'm going to put plus 24 because it's a positive 24. After that, we're going to divide both sides by 8, and by both sides, I mean every single term by 8. When we do that, these 8s cancel out. We have y equals 12 over 8 does not divide nicely. So we are going to have to simplify this fraction. So you need to think, what's a number that goes into both 12 and 8? Again, we cannot put a decimal here. It has to be a fraction because later you're going to have to count rise over run. And in order to do that, it has to be a fraction. So 12 and 8, I could divide both of those by 4. If I do that, 12 divided by 4 is 3. 8 divided by 4 is 2, so 12 over 8 simplifies to 3 halves, and then we bring down the x with it, and then 24 divided by 8 would give us a plus 3 here. So then this would be our final answer in slope-intercept form. Just another reminder, you do have to simplify that fraction every single time. Last problem for the front side here, we have number 7, write linear equations. In the first quarter of 2012, there were 183 millions of users of a popular social media site in North America. There's a typo there, sorry. The number of users increased by an average of 9 million per year since 2012. Write an equation that represents the number of users in millions of the social media site in North America after 2012. So we are writing an equation in slope-intercept form. So again, our goal here, y equals mx plus b. We need to know what m is, and we need to know what b is. Remember, m is the slope, and b is the y-intercept. Your slope is your rate of change. How are things changing? The y-intercept is just a starting point. Okay, so with that being said, our rate of change, we'll notice right here, it says increasing by an average of 9 million per year. That's how we know it's a rate of change. So we know that our m is 9. Then the other thing we have to find is what's the starting point? Well, we know that they're starting from 2012. We know that there was 180 million users to start with. So then we know that this is going to be 183. Now you'll notice it's also in millions, but this says to write an equation in millions. So we don't have to actually write 9 million or 183 million. We're just going to use 9 and 183. Using that information, we're going to go ahead and actually plug that in. So we have y equals m, which is 9, x plus b, which would be 183. That's our final answer. So the tricky part about the word problems is figuring out which one's your starting value and which one's your actual rate of change or your slope. Once you know what those two values are, plugging it into slope-intercept form goes pretty quickly. So that is it for the front. Let's go ahead and go to the back side. Okay, on the back here, we have graphing linear functions in slope-intercept form. So first things first, we have number 8, slope of negative 3 halves and a y-intercept of 4. So I'm going to go ahead and just write this in slope-intercept form just so we can keep practicing that. So we have y equals negative 3 halves x, and then plus 4. And you'll actually notice that instead of having the negative out in front of 3/2, I went ahead and put it with the 3 because I only want one of those numbers to be negative. They can't both be negative. So then after that, I'm going to identify m is -3/2 and b is 4. That would be my slope and my y-intercept. Now, when we go to graph, we always do our y-intercept first because I know that a y-intercept crosses the y-axis at whatever number b is. So because it crosses at 4, 1, 2, 3, 4, I'm going to put a dot at 4. That's what we always start with. Then we count the slope second. So think of it as like the reverse order of the equation that they give you, right? Now remember, slope is always counted as rise over run. So we're going to rise -3. So that actually means down 3. So we'd go from the pink dot, 1, 2, 3 down, and then run 2. Since it's positive, we're going to run to the right. So again, to reiterate that, we started at this pink dot right here. We went down 3, 1, 2, 3, and then over to the right 2, 1, 2. Because it was a -3 would be down 3, +2 would go to the right 2. Now, after you've done that once, you need to do it a few more times. You need 5 total points on your graph. So from this orange dot, down 3, 1, 2, 3, over 2 to the right. Down 3, right 2, down 3, right 2. Now that I have 5 points on my graph, I'm going to go ahead and get my straight edge tool here and draw a straight line that goes through those points with arrows on the end of them. Make sure you're using a ruler for this. So if you need to pause the video to go get a ruler, please go do that at this time. Okay, looking at number 9, I notice right off the bat that it is not in slope-intercept form. And in order for me to graph, it has to be in slope-intercept form. So I'm going to go ahead and subtract 12x from both sides. So then we have -3y equals -12x plus 18. Divide both sides, everything, by -3. And we have y equals -12 divided by -3 would give us a positive 4x. And then 18 divided by -3 would be -6. Again, identifying my m would be 4 and my b would be -6. And then again, we always graph our y-intercept first. So that's going to be at -6. So 1, 2, 3, 4, 5, 6 going down. Now we have our slope that we need to count next. However, this is just 4, but we need it to be rise over run. So there has to be a number on the bottom. It's actually over 1. So from the purple point, we're going to rise 4. So 1, 2, 3, 4, and then run 1. So this is going to be where my next dot is going to go. And then we do the same thing over again. So up 1, 2, 3, 4, right 1, because they're both positive. So then up again, 1, 2, 3, 4, right 1. And one more time, 1, 2, 3, 4, puts me right at the top of the graph there. And then again, getting my straight edge. Let's redo that. I kind of missed my points there. There we go. And then again, drawing arrows here to make sure that my line goes forever and ever and ever. Okay, looking at number 10, y is by itself, but it kind of looks a little funny. So here's something to talk about really quick. This is technically +0 because there's nothing there for our b value. So if we were to identify our m, it would be -1, technically -1 over 1, because we know that that fraction helps us count rise over run. And then our b value would actually be 0. So then again, we always start with our b value first, and that starts at 0. And then we have our slope of -1 over 1. So from the blue dot, -1 would be down 1. Then we have 1, so that would be right 1. Down 1, right 1, down 1, right 1, down 1, right 1. And there are our points. So then we're going to go ahead and go back to our straight edge and put arrows on the line. So something else that I would like to bring to your attention Right here, this slope was negative, so this line went down from left to right. This slope was positive, so it went up from left to right. And then this slope was negative, so it went down from left to right. That's actually a really good way to check your lines to see if you have them going in the right direction. Okay, moving on down here to 11 through 13. I noticed that all of these are actually in slope-intercept form for us, so we are ready to just go ahead and identify our m would be 1/2 and b would be -7. So then again, I always start with the b value or the y-intercept, so then down 1, 2, 3, 4, 5, 6, 7. And then counting our slope of 1/2, again, the 1 would be our rise, the 2 would be our run. So we're going to rise 1, run 2, rise 1, run 2, rise 1, run 2. And again, these are both positive numbers, so I'm going up and to the right because that would be the positive direction for each of those words there. So then switching over to my straight edge again. And then drawing arrows on each of those lines. Okay, 12 and 13 look a little bit different. Notice on 12, there is no x. Notice on 13, there's no y. So if you're down to one letter, it's actually going to be part of that Hoy-Vux statement. So if I write Hoy-Vux here, we have to figure out if y equals 2 is part of Hoy or Vux. Now this one's pretty easy to clarify or to see which one it is, because if it's y, Hoy is the one that has the y with it. Now, the only reason that this is helpful is because this tells us what the line looks like. The H stands for horizontal. And again, remember, because it's y equals 2, it has to cross the y-axis at 2. So that can be my dot there. And then if it's a horizontal line, I'm just going to put a few dots here that show a horizontal line before I actually connect all of those points. So there would be our graph for number 12. Notice there wasn't a slope that we technically counted. The slope of this line is 0, but because it's horizontal, there's really no counting that needs to be done. So then looking at 13, I see x equals a number. So again, I'm going to put Hoy-Vux here. And then the only one that has x in it would be Vux. And the V tells us what the line looks like. It's a vertical line, and it has to cross the x-axis at -5. So 1, 2, 3, 4, 5 to the left would be here. A vertical line goes up and down, so I'm going to add some points here. Again, remember, you're supposed to have 5 points for every graph. So then I'm going to go ahead and draw my line and put arrows on my graph. So Hoy, horizontal line when it's y equals a number. Again, if you remember from the front, we wrote that this was y equals a plain number. There's no x there. This one right here would be x equals just a number. Okay. Moving on here to our last problem, we have number 14. Suppose regular gas costs $2.50 per gallon. You can purchase a car wash at the gas station for $5. So we have $2.50, $5. Write an equation in slope-intercept form. So again, in y equals mx plus b, where again, you have to know what m is and you have to know what b is in order to do that. Then it's going to say graph the function, and then it wants us to actually go a step further, and we'll talk about that when we get to that point. So starting with just writing the equation in slope-intercept form. Again, like we talked about very briefly on the front, you do need to figure out what's the rate of change, how is it going to change, and then what's the starting point. So this one's a little bit trickier than the one on the front. Your starting point for this problem is going to be your $5. When you buy that car wash, it doesn't matter what kind of car you have. It doesn't matter how far you're going to drive or whatever it might be. You are paying $5 for that car wash. That is the starting value of what you're going to pay for. Then after that, gas is going to cost $2.50 per gallon. So basically when you see the word per, or there's several other words that you could see, but the two that we've had so far in our notes right now are per. For every is another example of a phrase that you could see. So that is going to be our rate of change or our slope. So 2.5. That is going to depend on how much gas you buy. If you buy 10 gallons of gas, that's going to be a very different price than buying 20 gallons of gas. So that's where that change comes into play. So then if we go to actually write our equation here, we have y equals m, which would be 2.50 times x, and then plus b would be plus 2.5. So there's our equation in slope-intercept form. Then it says graph the function. So we're going to go ahead and do that really quick. Starting with our b value, we go up to 5. Now, this is where it gets a little bit trickier. Our slope right now is 2.5, technically 0, over 1. If you notice, though, from 5 to 10, that goes up 5. Well, I don't want to go up 5. I want to go up 2.5. So I'm actually going to go up halfway and then over 1. That would be going up 2.5 over 1. So on some of these graphs, you have to be very careful. When they're labeled for you, you have to make sure you're counting by the right number. If there's no labels at all, you can assume it's just counting by ones, just like we did up above on the other problems. So going up 2.5 over 1, up 2.5 over 1 would go here. That would be my next point. And then up 2.5 again over 1 would be right here. Up 2.5 over 1 would be right here. That gets me my 5 points on my graph. I'm going to go ahead and switch over to my straight edge. And we're going to go ahead and draw this line. And then I'm going to put arrows on my line. And actually, I said arrows. There's only going to be one arrow because, again, we cannot go negative here. This would not make sense to go negative for gallons of gas. We're only going to go positive. So you'll notice I have one arrow right here that's going forever to the right because we could buy more than 10 gallons of gas. We could keep going this way, but we cannot keep going this way. Okay? So after that, we've graphed the function. Now the last thing they want us to do is find the cost of purchasing a car wash and 8 gallons of gas. So basically they want us to either do one of two things. One, we could go to the graph and look at 8 gallons of gas and follow this up all the way up here to figure out this point, which would be $25. So that's one way we could find the answer. Another way we could find the answer is actually plug 8 in for x right here. So we would have y equals 2.5 0 times 8 plus 5. So then this would actually give us y equals 250 times 8 would be 20 plus 5. Our final answer here would be y equals 25. So no matter what, either way, if you look at the graph or if you plug it in, you end up with the same answer. Since it's a word problem, though, we do have to answer in words. So we could write, if you purchase a car wash and 8 gallons of gas, it would cost $25. Oops, forgot to label. There we go. $25. So there's our answer. So this word problem had a lot going on, just to make sure we're all on the same page here. First thing they wanted us to do is write the equation. That's this right here. Next thing they wanted us to do is actually graph it. So that's this right here. And then they wanted us to find how much it would cost for 8 gallons of gas in a car wash. So that is our final answer here. And that is it for our notes.